In this video, we are going to talk about applications of exponential growth and decay. But before we do that, we need to do a little warm-up of how we convert percents into a decimal form. So anytime we have a percent, so I'll illustrate this first one, we know that the decimal point would technically occur after the 45. It'd be 45.0. So to convert 45% into a decimal, I'm going to take that decimal place and I'm going to move 2 places to the left. And so 45% would be the same as 0.45. So again, let's say I had 6%. The decimal would be after the 6, 1, 2. I'd have 0.06 would be that decimal. 12%, if I have 12, the decimal would be after the 12, boop, boop, 0.12. 2.5%. Again, I move this decimal 1, 2 spots would be 0.025. So converting percents to decimals are going to be really important for the problems that we're doing today. That's why I wanted to review this skill. So our objective for today is to be able to write a model for exponential growth and decay and use them to solve real-life situations. So we have 2 equations that are going to look really similar. Our exponential growth, which is y equals a times 1 plus r to the t, and exponential decay, which is y equals a times 1 minus r to the t. Notice that our growth formula has a plus sign versus our decay formula has a minus sign. Otherwise, all the variables are all in the same spot. So let's talk about what they mean. So if I'm talking about my a value, that's my initial value or amount. So that's starting amount, that initial value. My R is the rate of growth or decay. Depending on the problem, it's that rate of growth or decay. And this is when we have to take that percent and change it to a decimal. And last but not least, we have the t, which we know that t represents our time in this scenario. So months, years, etc. All right, let's put this into action, looking at our first problem. In 2006, tuition at Illinois State University was $79.75 for 15 credit hours. This cost increased 12% each year. So if we're increasing, that means we're talking about growth. So I'm going to be using my formula on the left. So I'm going to be using this formula. Write an exponential model that represents the situation. So what's my initial amount? My initial amount was that $4,079.75. My rate of growth was 12%, but I want to take that 12% and turn it into a decimal, so it'd be 0.12. So always write our rate as a decimal. So I'm now going to plug these into my formula because they told me to leave it in terms of t, so I'm not plugging in anything for t. So I'm going to have y equals 4,079.75 times 1 plus 0.112 to the t power. I'm going to simplify what's in my parentheses. 1 plus 0.12 is going to be 1.12. And so this would be the model that represents the rate of tuition increase. Now part B says, what will the tuition be in 2020? So now we're talking about time. So let's think about t. So we started in 2006 up here. So I'm going to do 2020 minus 2006, and that means my t is going to be 14 years. So I'm going to take this model that we wrote in part A. No need to reinvent the wheel. We already basically solved this problem. All I need to do now is plug in 14 for t. Then I'm going to type this in my calculator, $4,079.75, parentheses 1.12, close my parentheses, to the 14th power, and I'm going to get $19,938, and I get 1.96, but again, this is money. And so money, we're always going to do 2 decimal places. So this will round to $19,938.20. All right, let's do another example. When you buy your first car, you purchase it for $25,000. So again, this is my initial amount. However, the car depreciates, so we're talking about a decay situation, at a rate of 6% each year. And so 6% would be 0.06. So since it's a decay, I'm using my decay model, which is y equals a times 1 minus r to the t power. So again, I want us to write a model in terms of t years. So I'm going to have y equals 25,000 times 1 minus 0.06 to the t power. I'm going to simplify what's in my parentheses only. And I'm going to get 0.94 to the t power. Now, how much will the car be worth after 4 years? So I'm going to take that model that I just made in part A, and I'm going to plug in 4 for t. And again, we're still talking about money, so I'm going to round to 2 decimal places. So $19,518.72. All right, 3 says determine whether the function shows exponential growth or decay. So remember when we talked about growth, our b value was greater than 1. When we talked about decay, our b value was less than 1 but still greater than 0. So it's always going to be positive. So if I look here, my b value is what's in parentheses. Since my b is greater than 1, this represents a growth equation. Since my b is less than 1 but bigger than 0, this represents a decay equation. And again, in this case, my b is greater than 1 again, so this represents a growth equation. All right, go ahead and pause the video now, and I would like you to try 4 and 5 on your own. When you're ready to go over them, play the video. In number 4, you purchased a new boat for $16,000. So again, this is my A value. Each year, the boat decreases by 12%. So this is a decay equation, and my rate's going to be 0.12 because we always want to take that percent and turn it into a decimal. How much will the boat be worth after 5 years? So in this case, they did give me the t. So I'm going to use my decay equation. I'm going to substitute in everything I know. 16,000 for that original amount, 1 minus 0.12 to the 5th power. I'm going to simplify what's in my parentheses. I'll get 0.88 to the 5th power, and then I'm just going to type that whole thing in my calculator. And again, we want to round to 2 decimal places because we are talking about money. So I would get $8,443.71. In number 5, it says Chip and Joanna purchased real estate in Waco, Texas for their next episode of Fixer Upper for $85,000. Each year it increases by 5%. To the nearest dollar, how much will the real estate be worth in 2 years? So this is a growth equation, so I'm going to be using my growth equation. I know my initial amount is $85,000. I know that my rate, well, if it's 5%, move that decimal over 2 spots, it's going to be 0.05. And I know my time is 2 years. So I'm going to take everything I know and plug it into my equation. I'm always going to simplify what's in my parentheses. So I'll get 1.05. Then I'm going to type this whole thing in my calculator. And I'm going to get 93,712.5, but remember it's money, so it's 0.50. So $93,712.50 is how much the house will be worth in 2 years. Oh, it does say round to the nearest dollar, so I take that back. We would say it's $93,713 would be my final answer if we're rounding to that nearest dollar, because I would round up.